Hello, my name is Moses Ajay. As a way of supporting students who are struggling to understand some calculations involved in this module, Principle of Food Technology, I'm going to be adding voice over PowerPoint. And I hope you enjoy it. So, at the end of this presentation, you will be able to use physical quantities with confidence and use SIA unit correctly. Also, you will be able to solve simple problems involving velocity, acceleration, and force. Now, what are dimensions and physical quantities? Now, dimension are characteristics of object, condition, or event, and can be described quantitatively in terms of defined unit. Now, physical things such as length, time, these are dimension quantities, and they are called the primitive qualities. Now, other primitive qualities are temperature, electric current, amount of substance, and luminosity. And these qualities are called the base unit. We also have derived units. Derived units are formulated from this base unit. Now I'm going to be showing you some of the base units and some of the derived units, and from there we'll talk about the units for the SI unit for these quantities. Now, it is important that we have knowledge of dimension and units in food, because for us to describe property of food accurately, we need to describe them in terms of their units, in terms of their dimension. But because I'm going to be focusing more on the calculation aspect, so all these bits I believe you understand. Now, we know that SI units are very important. We know there's difference between 2 kilograms of salt and 2 grams of salt. So if somebody just said 2, we need to know, is it talking about 2 kilograms? Is it talking about 2 grams? So these are very, very important in new product development. We remember what happened in 1999. The NASA the loss of NASA orbiter, this was due to a metric mishap, just because somebody do not put the right unit. So at the end of the day, they use the wrong materials for the construction, and we all know the story. So in food, in food, we also know that it's important we understand that if I want to make a product, I have to use the appropriate ingredients in terms of the required quantities. And how do I get these required quantities? Is by having the appropriate unit. Now, 2 kilogram, as I mentioned earlier, is different from 2 grams. So SI units, the understanding, the knowledge of SI units is very, very important for food technologies, for food food processors. So we also know in terms of the recommended daily intakes for some food. So we need to use the appropriate unit in our product, so that people can know that this is what they are buying, and this is the amount of this material that is present. Now, what are the base quantities? Now we have length, mass, time, electric current, temperature, amount of substance, luminous intensity. Now, and here we know that length is measured in meter and the unit symbol is m. Mass is measured in kilogram and the unit symbol is kg. Time is measured in seconds and the unit symbol is x. So these are the base quantities, and it's important for us to know all these base quantities, because every other quantity that we have we derive them. The other quantities are derived from this base unit. So it is important for us to understand this base units. Now let's go to the derived unit. Now, for example, let's start with area. Area we know is defined as length multiplied by breadth. Now, and we know from the previous slide that our length, whether length or breadth or height, they are all measured in meter. So we know that our length is measured in meter, our breadth is measured in meter. So our area will measure in meter multiplied by meter. That is why we have meter square. Now we know volume is defined as length multiplied by breadth multiplied by height. And so we know this is meter, this is breadth is also a meter, this height is also a meter. So by multiplying all of them together, we have meter cube. Now this may look straightforward. Yes, it's every one of them is very straightforward if you apply the same principle. Now let's go to density. Density is defined as mass over volume. We know that the unit of mass in our previous slide is in kilogram, and just here we know that our volume is measured in meter cube. So our density is going to be measured in kilogram divided by meter cube, so which is defined as kilogram per cubic meter. So our velocity, we know velocity or speed is defined as distance over time, and we know from previous slide again that our distance is measured in meter. Distance distance can be in length, can be in breadth, can be in height, so it's measured in meter. So and our time is measured from our previous slide, we know that our time is measured in seconds. So our velocity or speed will be meter all over seconds, meter divided by seconds. So that is meter per seconds. Yes, I would like to encourage us to pause this video at this junction and try to attempt the following: the unit for acceleration, the unit for force, the unit for pressure, the unit for work, the unit for power. Now don't forget that our acceleration is defined as velocity over time. So to get the unit of acceleration, all you need to do is to look at the unit of velocity, look at the unit of time, do the appropriate calculation, then you get your unit of acceleration. Then for force, we know that our force is mass multiplied by acceleration. Then look at the unit of mass. We have that in our previous slide. Don't forget, we have that to be kilogram. Then look at the unit of acceleration. Whatever you get here as your unit of acceleration, multiply that by mass, then you have your unit of acceleration. Then for power, for pressure or stress, you know that this should be P, this is not F, this should be P. P equals our pressure or stress is given as force over area. So we know the unit of force, what you have got in here, then you know the area to be meter square. So from there you can get your pressure, the unit of your pressure. Then for work done or energy or quantity of heat, we know that it's going to be force multiplied by distance. Then we know the unit of force from whatever you get here. Then we know the unit of distance will be in meter from previous slide. Then you will get the unit of work. And again, power is the rate of doing work. So you know that will be work done over time. So from the work done from the unit you get here, then divided by time, you have the unit of your power. So I want you to pause the video now before you go to the next slide. Thank you. So these are the solutions for the problem. Now we can see that our force equals mass. Sorry, our acceleration. Yeah, let's start from an acceleration. Acceleration equals velocity over time. So we know that our velocity is meter per second. Then divide again by another time. So it's going to be meter divided by second square. Now you have two. You have two of the quantity time as the denominator. You have two of time of the quantity time as the denominator. So we have meter square. So the same applies to force, which is mass multiplied by acceleration. So please don't forget this is P. This is not F, because F here has been defined as force. So here we have mass multiplied by acceleration, which as our force, and our force is given to us as our mass is given to us as kilogram, and our acceleration is given to us as meter per second square. When you multiply them together, you get kilogram meter per second square. But in order to make things easy for ourselves, we represent this as Newton. Kilogram meter per second square is the same thing as Newton. You can, just like we have different names, Moses, Amolushei, Amajai. You can call me any of these names. They are mine. So the same applies to this quantity. Force can be in Newton. Force can be in kilogram per meters, kilogram meter per second square. So depending on to make things easy for ourselves, we prefer to use N. What is the unit of force? Newton. N is easy. Is easier to remember. If we compare it to kilogram meter per second square. The same thing applies to pressure. Now, very complex. A unit with three different derived units, kilogram meter second square. So to make things easy for ourselves, you simply call it Pascal, PA. And don't forget, this is the SI unit. It has to be in kilogram meter per second square. If this one is in gram or this is in centimeter, you cannot say that that is in Pascal. Please take note of that. If you've calculated your pressure or stress using mass in gram or using distance in centimeter, so or you use your time in hours, you can equivalent you can say that that is in Pascal. So you need to take note that everything you've used, all that you've used within your computation is in SI unit. That is where you can say this is Pascal. The same applies for Newton. Now, if your mass is not in kilogram, or your distance is not in meter, or your time is not in seconds, whatever you get at the end of the day cannot be in Newton. So take note of that. You have to be consistent. Now, you have to be consistent. If, for example, if I've given you mass in 1,000 gram, and you forget to convert that to kilogram, you use it as it is, as in 1,000 gram, that will be, the unit will be whatever you get, gram per meter per second square. If the distance has been given to us in meter and second and time in second, that will be gram meter per second square, and that can never be Newton, because the mass has been, the mass that you use for your computation is in gram, not in kilogram. So just take note, whenever you are doing your calculation for force or for any of the derived unit, make sure you use the SI unit for the individual components that you have in the computation. Make sure you use the SI unit. If you use the SI unit, you can arrive at the final answer and simply say, for force, my unit is Newton. For pressure, my unit is Pascal. For work done, my unit is Joule. For heat energy, my unit is Joule, because you use the SI unit for your computation. Now, power, don't forget, is work done over time, and that is going to be Joule per seconds. So, and we can simply say that is going to be in watts. So once you've used SI unit for all the components involved in the calculations, you would definitely be saying, yes, my final unit for power equals watts. I hope you understand. Please, if you have any question, please do not hesitate to get in touch with me, and I will continue to encourage the use of Blackboard discussion board, so that we can so that other students can benefit from the discussion. So this is practice question number 1. Now I want us to find the unit of x and y. If x is defined as this and y is defined as this, what is the unit of x? What is the unit of y? The SI unit of x, the SI unit of y. Now I said x is defined as vt plus at squared. Now, and I've said that our v equals velocity, our t is time, our a equals acceleration. Now, what is the unit of x? Simple. Now all you need to do is to go back here, look for your velocity. What is the unit? Look, what's the unit of your time? What's the unit of acceleration? What's the unit of your time? And then don't forget to multiply that by don't forget to square that. Now you will get the unit of AOX. So just make an attempt and see what let's see what you have. And for your y also, we know the unit of v, we know the unit of t, we know the unit of a, we know the unit of t. So all you need to do is just to substitute them in the formula and see what you have at the end of the day. For question number 2, a heat transfer surface area is given to us as 25 centimeter by 25 centimeter. I want us to calculate the value in centimeter square and in meter square. Don't forget, if you multiply 25 by 25 and you get 625, without giving me the unit, I do not know whether you are talking in centimeter square or meter square or in kilometer square or mile squares. So it is important you put the unit. When you put the unit there, I'm able to select the appropriate material for the process or for whatever thing I want to do. So unit is very important. Let's see, when you calculate the area in centimeter square and also calculate the area in meter square, you will see the difference between the two. Unit, very, very important. Now, a pipe has an internal diameter of, don't forget, area here is length times breadth. Now, for number 3, a pipe has an internal diameter of 48 millimeter. See, this is another thing, 48 millimeter, not centimeter, not meter. The question is asking us, calculate the cross-sectional area of the pipe. You can calculate the area in millimeters square, you can calculate the area in meter square, you can calculate the area in kilometer square, but My own recommendation would be, let's go with the SI unit. SI unit is like saying, let's have a language, a common language. When you have a common language, you avoid the implication of that, you avoid confusion. Now, although the US has their own units, UK has their own different units. They have their own metric. So, but the most important thing is when we have a common language, the SI unit. Let's use the SI unit for our computation. When you use the SI unit for our computation, we are all going to arrive at the same answer. For example, if you want to use, I won't be using, for me, I won't be using this diameter directly. I would prefer to convert it to meter. That's the SI unit. When I convert it to meter, I'm not saying it's wrong if you use 48 millimeter as your diameter. No, I'm not saying that. The formula to calculate the cross-sectional area of the pipe is very important. Your steps are very important. If you can show me your step, then we show me your step. If you start, for example, if you start with 48 millimeter in your formula and you now find the final answer and you now put meter square, that's wrong. It can't be right. So make sure you are consistent in whatever you're doing. Now we know that the area for calculating the cross-sectional area of the pipe is pi d square over 4. We know that is the area, pi d square over 4. Pi is 22 over 7. D here is the diameter that we've been given. Then we need to convert that, or if you want to leave it as it is, fine. But make sure you are consistent with whatever you're doing. Now, number 4. A current source occupies a volume of 0.03 meter cube. That's the volume, and has a mass of 1400 gram. Can you see something here? Now, this is given to us in SI unit. This is not given to us in SI unit. You can see 1400 gram is not SI unit. This is in SI unit. Now, the question says calculate the density of the liquid in kilogram per meter cube. So you need to take note of this. Now, before you can't just say yes. To do this, divide mass over volume, because we know from here that our density is given to us as mass over volume. But don't forget, here we are giving this mass in gram. Now, it is not a gram. If you calculate this as 1400 gram divided by 0.03 meter cube, your unit will be gram per meter cube. But that is not what I'm asking you to do here. I'm asking you to find the density for me in kilogram per meter cube. So in kilogram per meter cube, so you need to convert your mass to kilogram, and fortunately for us, we have our volume as 0.03 in meter cube, and B in kilogram per liter. Now this is interesting. Now we know that this we need to convert to kilogram, which we will do for question A. Then for our unit, we need to look for means of converting 0.03 meter cube to liter. Now, after you have done that conversion, then you will now divide them. You divide the mass that you have divided by the volume in liter. So then you have your final answer for B. So please take note of that. Number 5, a packing case of 10 kilogram rests on a surface. A constant that is the mass. Don't forget, that is the mass. Now, a constant force of 30 Newton is applied to the case, and the question says calculate the acceleration of the case. Now, the question says calculate the acceleration of the case. Now, going back to the formula. Now, the formula for acceleration is given to us as velocity over time. Now, you have the velocity over time as your acceleration. Sorry, let me go back to the question. The question says calculate the acceleration of the case. Now, yes. Now, if you look at what we're giving, we are not giving. We know that acceleration is velocity over time. But here, we are not giving velocity, we are not giving time. All we are giving here is force and mass. Then I think we should go and look beyond acceleration. Now, if you look at this, let's look at force. Our force here is given to us as mass multiplied by acceleration. So we know that our force equals mass and multiplied by acceleration. Now, going back to the formula, going back to the question here. Now, we are giving mass, we are giving force. Don't forget that our force equals mass multiplied by acceleration. We need to find out what is our acceleration. Our force equals mass times acceleration. Then you know what to do. Force equals mass multiplied by acceleration. You are giving the force to be 30, you be giving the mass to be 10, multiplied by acceleration, then you can do some computation, then you find your acceleration. Okay. Now B, work done. If the force that is applied to move the case, calculate the work if the force is applied to move the case by 2 meters. So if the force is applied to move the case by 2 meters, what is the work done? Now don't forget that work done equals what? Force multiplied by distance. You have the force, then you have the distance. I will take you to the formula again. Our work done here, or energy, equals force multiplied by distance. Now going back to what we are given, we know that the distance is 2 meters and we have force, then we can calculate our work done. The power, now the power equals the rate of doing work, which is work over time. So we have the work done here in B, then we have the time, so we can find the power. All right, don't forget, any question, do not hesitate to contact me. Now number 6, what is the pressure at the bottom of a large tank of water 25 meters deep? Now don't forget that you can calculate this with 1 meter square in terms of the area of the base. We want you to use 1 meter square as the cross-sectional area of the base of the tank, and we assume is the same, is uniform. Now we'll be given that the density of water is 100 kilogram per meter cube. The acceleration on Earth is 9.81 meter per second square. Yeah, for you to calculate this, for you to solve this problem, you will need to do a bit of research. Now here it's not straight. We are given the density, we are given the acceleration, and we want you to calculate the pressure. Now if you look at the formula here, the pressure is given as force over area. Okay, and we know that our force is given to us as mass multiplied by acceleration. We need to do a bit of combination of two formulas to solve this problem. Please attempt to solve this problem and get in touch with me if you have any question. Thank you so much for listening. Bye.